Hello and welcome back to Math with Patrick. Today is August 26th and we're solving problem number 238 from the Daily Epsilon calendar. And today's answer should be 26 because today is the 26th. So we just need to show why this number, 26, is just the same as this number, which I don't yet see to be 26. Looks like we have the square root of 300 plus the square root of 88,556. And then we're adding it to the square root of essentially the conjugate of this inside part. Conjugate just means that we're repeating the same values, but we just switch that middle sign. So instead of a plus sign between the 300 and that square root, we have a minus. So this number on the screen right now is supposed to be 26, and I don't see it yet. Although I think what we could do is square this value and see what happens. And there's been actually many problems like this on the calendar, and so I'm pretty sure that this is the right way to do it. We'll just do a lot of arithmetic today, and we'll find out that the answer is 26. I am going to do quickly 26 squared off to the side right here, and I'll just do 26 times 26 with like the standard multiplication procedure. And so once we get a number at the end of all of this computation, hopefully it'll match the one that I'm getting right here for 26 squared. Because again, this number is 26 and I'm now squaring it. So just doing that multiplication first, 6 times 6 is 36. 6 times 2 plus the 3 is 15. Here's a placeholder 0. 2 times 6 is 12. And then 2 times 2 plus the 1 is 5. And so I'm going to get 676 for 26 squared. So this number that I get here should also be 676. When you're multiplying a binomial by itself, a binomial just being something plus something or something minus something, like essentially two terms is where the name binomial comes from. First, you need to multiply the first by itself. So I'll essentially just undo the square root. So it'll be 300 plus root 88,556. Then I need to do 2 times the product of both of these terms. And so just for the sake of room, I'm just going to write it a little bit lower. It'll be 2 times, and then I'll need root 300 plus root 88,556 times, and then the other one, square root of 300 minus square root of 88,556. And then finally, I will add on the last term times itself, which, just like the first one, will just cancel out the square root sign. So we just got 300 minus root, same number, 88,556. So I do see some simplifications that we can make. First off, this square root cancels with that one. We're adding it up here and subtracting it down there. Second, the two 300s can just multiply or add together rather. So 300 plus 300 is 600. And then whenever you're multiplying two radicals, say like root 3 times root 5, you're usually, I was going to say always, but maybe there's a rule that, you're usually allowed to multiply them together like this. The one caveat is that if there are some negatives underneath, then this is not the same thing as just multiplying these two numbers and getting a positive 8. So this rule only works when we have non-negative values underneath our square root sign there. So I am just hoping that this value right here is positive. 300 squared is going to be 9 with 4 zeros after it. And then so this shows me that this number is bigger than that one. So yes, the number on the right side is positive. Anyways, we can now multiply the radicands before we take that square root. So 300 plus root 88,556, and then 300 minus root 88,556. And I'm going to simplify the stuff underneath the square root sign here. I see that we have a difference of squares, and whenever you have well, actually the factored form of a difference of squares. If you multiplied all this out, you would get a squared from these two. You get minus ab from these two. You get plus ab or ba from these two. And then finally a minus b squared. And these two terms cancel out as long as multiplication is commutative. In this case, it is. So we just get a squared minus b squared. So from this multiplication underneath the square root sign, I know I can square the first, which is going to be that 90,000 that we saw earlier, and then I can subtract it from this last term squared, and that once again cancels out the square root sign. So now we just get some kind of arithmetic problem that looks like this. Knowing that the answer is 676, I'm hoping that this number right here is 76. So we'll just see what happens. We need to do 90,000 minus 88,556. And I don't like doing this one with kind of all that sequential borrowing. And so what I actually like doing is subtracting one from the top and one from the bottom. And essentially, it's just the same borrowing thing. But I like it a little bit better. The reasoning here is like, say we have an easier problem like 10 minus 4, that's just 6. But if I take away one from the top and one from the bottom and I subtract those, I still get the same answer. And I like this strategy just because I don't have to worry about borrowing over and over and over again. So 1 below 90,000 is going to be an 8 with a bunch of 9s trailing after it. And then as long as I reduce this by 1, then I'll get the same difference here. And so it's just going to be a 4, a 4, a 4, a 1, and then a 0. So we got 600 plus 2 times root 1,444. And I don't know the square root of this number off the top of my head. I mean, kind of back solving right here, it should be whatever half of 76 is. And so that's going to be 38. Is that? It's 38 plus 38 is 76. Okay. So this should be the square root, or square rooting this should be 38, or in other words, squaring 38 should get me back to here. But when I do 8 times 8, oh yeah, no, that's 64. Okay. For some reason, I was thinking that this would be the number 6, but that's a little silly. So this bodes well because the 4 matches this one right here. 8 times 8 is 64. 8 times 3 is 24, plus the 6 is 30. Placeholder 0. 3 times 8 is another 24. 3 times 3 plus a 2 is 11. And then nice, 4, 4, 4, 1. So this shows that the square root of 1,444 is indeed 38. So we can now just do 2 times 38, and we already saw that that is 76. So overall, we do get 676, and the only way we could have gotten this number is if we squared the number, well, there are 2 ways to get the number 676 if you square some number. Either this number was positive 26 or negative 26. But we both saw already that this is a positive number, and we're adding it to another positive number. So there's no way that this number right here is anything else besides the number 26. So that's our answer. Whole bunch of arithmetic, a lot of squaring and square roots, but we're all done for now. So thanks for watching. I hope you enjoyed the video, and I'll see you tomorrow. Bye.